Alright, so this would correspond to section 5.8 in your book. How do you sketch these polynomial graphs? And there's two things that you need to look at to be able to do that without the graphing calculator. And one of them we've talked about before is the n behavior based on the degree of the whole polynomial. So we'll look at the end behavior. And if the function is even, and so you kind of want to start with this little sketch whenever you're doing these. If the function is even, then you should right away, if you're trying to remember what the end behavior is think y equals x squared, the most basic even function you can think of, which starts up and ends up. So even if it's degree 6 or 8 or 10, if it's even, it starts up and it ends up. If the function is odd, then you should right away think y equals x cubed. And if you forget, you can make a table of values, but you should know that it looks like that and it starts down and ends up. So any odd degree polynomial, like 7th degree, 9th degree, it'll start down and end up. And then of course this switches if the orientation is this is if the orientation is positive, because that's like A is positive. If A is negative, if I throw a negative in front for the orientation like this, y equals negative x squared, then it just flips. So it starts down and it ends down, just like the graph of y equals negative x squared. And if a negative orientation on an odd function is like y equals negative x cubed, and it starts up and it ends down. So you just, it's just the flip. Basically, it reflects over the x-axis. So that's one part of being able to sketch, and that's what you start with is the end behavior. And then the new thing that we looked at yesterday was the root behavior, depending on the exponent of the factor. So the root behavior, and so we'll make a table for that. So there's the type of root, there's the degree, and then what it graphically looks like. And whenever I say root, you could think a 0 or an x-intercept, those all mean the same thing. So the type of root, there's the degree of the factor, that the root comes from, and then we'll do a complete example. We'll do 2 examples. And then graphically, what does it look like? So let's say you have just a regular root. So that would be called, meaning the exponent is 1. That's just a regular single root that you're used to. The degree of the factor is 1, which you won't even see the exponent when it's 1. And that just crosses right over the x-axis. If the degree of the factor is squared once you've factored it, that's called a double root. And that means it won't go through. It'll actually be tangent to the x-axis, which looks kind of like it bounces off. It heads toward it, but it does not cross over. It touches and then it turns around. And then if it's cubed, if you have a triple root, that's degree 3, the exponent will be 3. And again, that crosses the x-axis, but it kind of flattens out as it goes through. And the higher the degree, the flatter it's going to get. And so this continues. You could have, degree 4 or 5, but whenever it's any odd degree, it's going to cross through the x-axis, and whenever it's an even degree, like 4th or 6th or 8, it will bounce off. So keeping all this in mind, let's do 2 complete examples of sketching these. And again, there's no calculator here. So example, let's try y equals x times x plus 2 squared times x minus 2 cubed. Okay, so this is our example. Okay, so we have the degree of the entire polynomial is, in this case, is 6, because you basically just add up all the exponents. There's an invisible little 1. This is x to the 1 power. So the degree of this whole thing is 6. 1 plus 2 plus 3 is 6. So that makes it an even function. Even function. And therefore, it starts up and it ends up. It might do some other things in between, but just like y equals x squared, it starts up and it ends up. So that's the overall. And then as far as the roots, or zeros or x-intercepts, they are, for this factor, the root is 0. And that's called a single root. I'll just write SR because it's to the 1 power. The root for this factor is -2, and that's squared, so that's a double root. And the root for this is 2, and it's cubed, so that's a triple root. So these are each of the factors. Each factor gives you a solution or a root. This is a single root because it's raised to the 1 power. That's double root raised to the 2 power. Triple root raised to the 3rd power. Now we're ready to sketch it. All we have to do, we don't do it exactly, we just do it approximately. Exactly will be for calculus. So we just use the x-axis and we put our roots down. So we have 0 is one of our roots, -2 is somewhere over here, and 2 is somewhere over there. You put those are the x-intercepts. So those are the only points we care about. Now we want to sketch it. So we just go like this. We know it starts up and ends up. So you put an up arrow here and an up arrow there because that's the end behavior, because it's an even function. It's degree 6. And then we just go through each root. So -2 is our first root. That's a double root. So we're headed toward it, but we don't cross over, we just bounce off of it. It's just tangent because it's a double root at -2. Then we go to 0. That's just a regular old single root, so we just pass right through it. And then 2 is a triple root. That also just crosses right through it, except it flattens out a little bit as it goes through. So that's roughly what the polynomial looks like. And that's how you do this. We're going to do one more example. Let's try y equals x minus 2 cubed times x plus 1 squared. So we have what is the degree? 5, because if we add up the exponents we would get 5. 3 plus 2 is 5. So it's in what kind of function? Odd. Nice. Odd function. So just like y equals x cubed, which is also odd, it will start down and end up. That's the end behavior. I'm not sure what happens in the middle yet, but that's the end behavior on the left side and the right side. Then our roots, we're going to list each one and say what type. So what's the root for this factor? And what kind of root is it? Triple root, TR. What kind of root here? -1, and it's a double root. Nice. So we just sketch it along. We just use the x-axis here, and we put our roots down at 2 and -1. And since the end it starts down and it ends up, we just put those arrows so we know where it's headed. Now as we approach -1, because it's a double root, it just is tangent, it touches and turns around. And 2, this makes perfect sense, it's a triple root, but just like y equals x cubed, it flattens out for a bit and then it goes up. And so that's what that graph looks like. And now we'll try some examples as a class.